Hello friends. Welcome to T Academy. I am going to start a new video series of previous GATE electrical engineering questions here. So in this video, I have considered the last 5 years questions paper, that is from the GATE 2022 2018 questions. Okay. So the reason why I am making this video series is nowadays if you are writing any PSU examinations, they are mostly focusing on the GATE and IES previous questions. Okay. So that's the reason why I have considered the last 5 years of GATE questions from the each topic. That is now I am going to discuss the networks basics. Next it will be statistical analysis. Next will be after that two port networks, three phase circuits, etc. like that. So I have considered only one particular topic, and that topic last 5 years GATE questions I am going to solve in this video here. I hope you like the video. If you are new to this channel, please subscribe to the channel and share with your friends here. Okay, the first question here, it is in the given, this question is asked in the GATE 2018, that is called 2 marks question here. The equivalent impedance Z equivalent for the infinite ladder circuit is as shown in figure. So infinite ladder circuit means, see here, this is going to be infinite like this. Okay, now here the infinite series starts from this particular point Z equivalent to from this point here, and from here to again the same network, whatever the network is there, the same elements are here also. Okay, that means I'll consider this equivalent value as Z equivalent here. Okay, so Z equivalent is there. So just what I have drawn here, I have drawn the same thing here. So let us consider here I am considering Z equivalent is equal to Z here. Okay, so Z is there, so 9 ohms, 5 ohms minus J1 ohms, and I am considering this equivalent value, equivalent network as Z here. Now just by uh, series parallel combinations, so Z will be, this Z will be equal to, this is J9 which is plus, which is in a parallel with the combination of J5 minus J4 and Z here. So that is what I have written here. Okay, now if you simplify this here, so J5 minus J1 means it's going to be J4, so J4 is in parallel with the Z here, so Z is equal to J9 plus J4 into Z divided by J4 plus Z here. Now again further simplification here, what I have done is Z minus J9, okay, this one, into Z plus J4 is equal to J4 into Z. So further simplification here, you will get the equation as characteristic equation as Z square minus 9 J9Z plus 36 is equal to 0 here. Now we need to find the roots of this equation here. Z12 for now will be minus B plus or minus square root of B square minus 4AC by 2A. So substitute the values, A is equal to 1, B is equal to minus 9J, C is equal to 36 in that equation. Then plus 9J plus or minus square root of 9 square J 9 square minus 4 into 1 into 36 divided by 2A. We know that J square is nothing but minus 1 here. So for that, if you are substituting this equation, you will get it as plus 9J 9J plus or minus square root of minus 81 minus 144. It is going to be 225. Okay, minus sign. So minus 225 square root of means. Again we simplify this one, we will get 9J plus or minus J15 divided by 2. So again simplifying this one, 1 plus sign, 1 minus sign. So 9 plus 15J, 9 minus 15J. So 9 plus 15J means 24J by 2 or minus 6J by 2. Okay, so 24J by 2 means answer will be 12J here. So in the given option, if there is a minus 3J, okay, minus 3J is, that means that will be, that will also be another option. But in the given options, answer will be plus 2J is the answer here. So that is the question asked in the ladder network. So suppose in case of the any transco examination or in the AE examination, the same question is asked means, then you have to follow the same procedure and you have to simplify it. So most of the times in PSUs the same question is repeated, so you have to remember the answers also. Okay, next question friends, next question here, this question is asked in the GATE 2009 and for this for 1 mark question here. The current I flowing in the circuit shown the below amperes, okay, round off to the 1 decimal place is, so this is the question asked here. So for this question, assuming that here there is a node point here, X is there, okay, and the voltage across this element, that is the current source, will be, will consider as a Vx here. Applying this concept here, applying the concept of node analysis, what you can write here, it is a Vx, okay, Vx minus 20 divided by 2. So this will be current here, and the current entering to this terminal is negative minus 2, okay, plus Vx minus 5i divided by 3 is equal to 0. So this will be the equation. And second equation, considering this loop here, minus 20 plus 2 into I plus Vx is equal to 0. So these are the two equations. With the help of these two equations, we can find the current value here. So see, I have written the same equation here at node analysis. Vx minus 20 by 2 minus 2 plus Vx minus 5i by 3 is equal to 0. By applying the KVL in the loop, in this loop here, I have written the equation minus 20 plus 2i plus Vx is equal to 0. So substituting these two equations, 2 in 1 means here I will substitute the value of Vx, okay, here in this case. Now, okay, let me check here. Okay, fine. Now here substituting Vx means 20 minus 2i minus 20 by 2. You simplify this one, you will get the answer as I is equal to 1.4 amperes here. Okay, so we'll move to the next question here. 1.4 amperes is the answer. So answer will be what? Okay, so that is right. Next one, right. The current through the ammeters A2 and A3 in the figure, one at an angle 10 degrees, one at an angle 70 degrees are respectively the reading of the ammeter A1. So the questions what I am taking are from the GATE examination, so where the calculator is allowed. But in case of your AE examinations, you have to remember the answers. Okay, in competition. Okay, you said that sir, no calculator allowed. Then how can you solve the problem? So that's about all about the competition. So you have to remember some basic questions answers also, right? So here the current I1 is nothing but the sum of applying the node analysis here. Okay, so it is a current entering is equal to current leaving. Okay, plus I2 plus I3. So I2 will be what? At 1 at an angle 10 degrees plus 1 at an angle 70 degrees. Okay, either you can add in the calculator directly, or you can convert into polar form to rectangular form and rectangular form to again addition here. So I have done here, it is 1 at an angle 10 plus 1 at an angle 70, and if you are converting this 1 at an angle 10 into its rectangular form, 0.984 plus I into 0.1736 plus 1 at an angle 70 will give you to 0.342 plus I into 0.9396. So again if we add addition and we will convert it to polar form here, then you will get a root 3 at an angle 40 degrees. It's nothing but 1.732 at an angle 40 degrees will be the answer here. Okay, so next question here, right here in the given circuit. This question is asked in the GATE 2021, which is for 1 mark question here. Okay, basics. In the given circuit, the voltage Vy to be 0. So this is the voltage Vy is equal to 0. Okay, the value of beta should be, so here we have a voltage dependent voltage source, beta into Vs is there. Okay, now apply the analysis here. So what we have to do is, I will apply node analysis. First, assuming that Vx should be greater than Vy. So based on this concept, apply the node analysis. So node analysis, right? So Vx minus 6 volts divided by 1 plus Vx by 4 plus Vx minus Vy by 2 is equal to 0. So this will be our first equation. Second equation, we are considering that Vy should be greater than Vx. Based on this concept, we will get Vy minus Vx by 2, current entering at the terminal as a minus 2, plus Vy minus beta into Vx divided by 3 is equal to 0. So these are the two equations we have to simplify. So I have written the first equation here already. Here it is, as you can see, and we know that the Vy value is 0 by substituting Vy. So Vx minus 0 by 2, Vx by 2 plus Vx by 1 minus 6 by 1 plus Vx by 4. So simplifying this Vx, we will get the answer as a 24 by 7 volts here. Okay, now similarly by nodal analysis at Vy, so Vy already written equation here, the equation already written here, that equation is considered here. Vy minus Vx by 2 minus 2 plus Vy minus beta Vx by 3 equal to 0. We know that Vy is 0. From this we will place 0 here, minus Vx by 2 minus 2 0 minus beta Vx by 3. Again simplifying this. Okay, so simplifying this mathematical equation, we will get the answer as a minus 3.25 will be the answer here. So minus 3.25 will be the correct answer. So next question here. So this question is asked in the GATE 2022, and this is for 1 mark question here. Okay, now see here, In the circuit shown below, the magnitude of the V1 in volts across a 8 kilo ohms resistor is. So here we need to find the voltage across the 8 kilo ohms. So what we can say, V1 is nothing but 8 kilo ohms into current flowing here, it is I. So let the equation number 1 here. Now next here, apply the KVL inside the loop here. Here is a short circuit right now, so we can apply the KVL inside the loop, or we can go for the node analysis also. So okay, let's see here. So minus 75 here, minus 75 plus, so I write in minus 75 plus here it is 2 kilo ohms into current I plus 0.5 V1 is equal to 0. Okay, so there are two unknowns and we have two equations. Okay, substitute find the value of I here. Okay, so I value found as 75 minus 0.5 V1 divided by 2K. Substitute this equation into the above equation what I have written here. So 2 in 1 is equal to V1 is equal to 8 kilo ohms into I value 75 minus 0.5 V1 divided by 2K. Again simplifying this, so 2 gets cancelled, 4 here, so 4 into 75 minus 0.5 V1. Okay, again simplifying this, so V1 by 4 plus 0.5 is equal to 75. Simplifying with this one, we will get the answer as a V1 is equal to 100 volts for this question here. Okay, so thank you friends, that's it from the basics. In the next upcoming video, we will discuss about the gate electrical questions of the previous 5 years in the topic of steady state analysis. Okay, thank you friends, have a nice day. Please share the video and like the video.